Forecasting the weather always comes with a little uncertainty. It's a mix of science, technology, and human discernment. Traditional forecasts are built on physics-based numerical weather prediction models, or NWPs, which can sometimes miss the mark, especially when it comes to rapidly changing weather events. Now, a generation of artificial intelligence forecasting models is emerging, offering meteorologists another tool to improve their accuracy. Rather than replacing human forecasters or traditional models, AI has the potential to emphasize them.
Traditional numerical weather prediction then uses computer code that encodes the laws of physics, things like conservation of mass, energy, and momentum, to make a forecast. What's different about AI models is we instead use AI to do pattern matching. We learn how to take an atmospheric state at one time and match that to an atmospheric state, say 6 hours in the future. So in that case, we're not using the laws of physics directly, but learning them from lots of examples.
AI NWP models' unique development through thousands of case studies make them a nifty tool for large-scale weather events.
AI models are very good at pattern matching and pattern recognition. So they can do a good job at identifying a pattern for an extreme weather event a number of days in the future, maybe the track of a tropical cyclone or the location of a northeast winter storm. What they are yet struggling with is to predict the small-scale features.
Because small-scale phenomena like thunderstorms have so many nuances to their development, AI NWP cannot currently predict their formation far in advance. But there is research being done attempting to amend this shortcoming.
So we are currently building an AI model for convection initiation. In other words, imagine there's a big sporting event in State College, and we want to know, will it rain in the next hour? So what our AI model does is takes a look at satellite imagery and predicts which clouds might just pass the stadium by versus develop into a thunderstorm that might necessitate action to prevent harm to people and property. AI models are very good at matching patterns. So if you give it many thousands of examples of clouds and tell it which of these developed into a thunderstorm and which did not, it then becomes really good at applying it to a new cloud it hasn't seen before and able to make an accurate prediction.
Greybush's AI research model analyzes satellite imagery to predict which clouds might pass overhead harmlessly and which could turn into heavy rain or severe thunderstorms. Short-term forecasting is largely based on current satellite and radar signatures. Before anything appears on radar, an AI model could tip forecasters off to potential severe weather. AI modeling could be used to increase accuracy and shorten the lead time to warn for severe weather events across the country. When a tornado or flash flood threat appears, every minute counts. With AI, forecasters might detect dangerous situations minutes earlier, giving communities extra time to take proper safety precautions.
We've had some good success stories where the AI model has predicted that clouds would develop into a thunderstorm, whereas the most state-of-the-art models for numerical weather prediction failed to predict the storm to develop. So in a particular case, clouds are building over State College. If one looked at the state-of-the-art National Weather Service model, the HER, which is usually very good in these situations, you would find that this model showed that there would not be any showers in the next hour. But using the AI model, we were able to see that the clouds were building and growing and showed signs of developing in a thunderstorm. And sure enough, within the next 10-15 minutes, a thunderstorm did develop over State College that would not have been predicted well with traditional methods. In the future, AI modelings will probably be used to increase the accuracy as well as shorten the lead time to help us warn for severe weather events.
In less life-threatening scenarios, AI can also refine forecasts for less extreme but high-impact situations like outdoor gatherings or sporting events. Forecasters could be able to pinpoint when a thunderstorm will form near a stadium or whether a light rain shower will clear before kickoff. By analyzing satellite and radar imagery in real time, AI could help meteorologists give more confident, location-specific guidance than traditional models. AI forecasting models also have the potential to be more cost-effective when compared to traditional NWP. Similar to solar panels, AI models are expensive to create but are more energy efficient once produced.
AI models are expensive to train, but once you've trained the model, they're very fast to run. For example, the GFS model that we're used to seeing on Weather World may take an hour to run on a supercomputer, whereas the AI model can be run in a minute on a computer here at Penn State. So whereas meteorology has used some simple forms of AI for decades, More recently, only the last 3 or 4 years have we seen AI models that are as good as, and in some cases better than, traditional numerical weather prediction. This field is changing rapidly. Right now, the biggest advances have been made for medium-term forecasts, let's say out to the next 7 days, but we expect AI to also potentially improve other scales of forecasting, including nowcasting, short-term prediction, and perhaps longer-term prediction as well. AI models may be used together with physics-based models in the future. AI models can make forecasts quickly, and we can make many different ensemble members or different potential scenarios for the weather very cheaply. But we also may want physics-based models to increase our confidence in the reliability of these forecasts and to get the best of both worlds from these two approaches.
AI models have the potential to be a wonderful new tool for weather forecasters, but they still have their limitations. It is unlikely that they'll entirely replace traditional physics-based models, and they certainly won't replace human forecasters. AI has its own strengths that can be used alongside regular models to upgrade current forecasting practices. Through a combination of AI and traditional models, forecasters will have increased options to iron out uncertainty in their forecasts. For Weather World, I'm Rebecca Newell.